Alright, Chapter 7, 721, Titanium Welding. General, titanium is soft silver white, medium strength metal with a very good corrosion resistant, high strength with a weight ratio. The tensile strength increases as the temperature decreases. Titanium has a low impact creep strength and seizes tendency to temperatures above 800 degrees Fahrenheit. Titanium has a high affinity of oxygen and other gases elevated with the temperature and for a reason cannot be welded and with any other processes utilized with the flux of the when metals do expose to the atmosphere. Minor and amounts of impurities causes titanium to become brittle. Titanium has characteristics known as ductile brittle transmission. Or transition. This refers to the temperature at which metal breaks with a brittle manner rather than ductile fashion. Recrystallization metal during welding can raise the transition temperature, containing contamination during the high temperature period. Impurities can raise transition temperature period of the high impurities can raise transition temperature. So material is better material is bitter at room temperature. It contains a curve with a transition temperature raised efficiently. It makes welding worthless. Gas contamination occurs with the temperatures below the melting point of the metal. These temperatures range from 700 degrees to 1,000 degrees Fahrenheit. At room temperature, titanium has impervious oxide coating that results further reaction of the air. The oxide coating melts and the temperature considerably higher than a melting point of the base metal that creates the problem. The high oxidizing coating may enter the molten weld metal, create discontinuities with a greatly reduce the strength of the ductility of the metal. Procedure welding titanium. Titanium alloys are similar to the other metals. Some processes are oxyacetylene arc welding processes use active gases. Cannot be used with a high chemical activity titanium and its sensitivity to embrittlement by contamination processes are satisfactory for welding titanium. Titanium alloys also included gas shield, metal arc welding, gas, tungsten arc welding, spot seam, flash pressure welding. Special procedures must be employed when using gas shield welding process. These special procedures include using large gas nozzles, trailing shields to shield the face of the weld over the area, the backing bars of the knot, and air the gas to the shield of the back of the weld so the air are also used. Not only molten welded metal, but material heated up to 1,000 degrees Fahrenheit by the weld must be adequately shielded in order to prevent embrittlement. All these processes provide shielding of the molten welded metal heated affected zone prior to welding titanium. Its alloys must always be free of scale and other material that might cause weld contamination. Alright, surface preparation. Warning: nitric acid used for the pre-cleaning titanium and air gas shield arc welding high tide corrosive goggles, gloves, rubber aprons must be worn with a handling acid. Acidic solutions do not inhale gases or mist when spilled. Body of clothing washed immediately with a large quantity of cold water. Seeking medical help with never pour out water into acid when preparing a solution. Instead, pour acid into water. Always mix acid water slowly. Perform cleaning operations only as well ventilated areas. Caustic chemicals include hydro used for the pre-cleaning titanium for an air gas shield arc welding is highly toxic corrosive. Goggles, rubber gloves, and rubber aprons must be worn. Handling these kinds of chemicals do not inhale a gas or mist when spilled on the body or clothing. Use immediately large quantities of water and seek medical help. Special care should also be taken all the time times to prevent any of the water from coming in contact with a molten bath or any large amount of the sodium hydrate, which will cause a formation of highly explosive hydrogen gas. Surface cleaning is important. Preparing titanium and its alloys. Welding. Proper surface cleaning prior to the welding reduces contamination of the weld due to surface scale of the other foreign materials. Small amounts of contamination can render titanium completely brittle. Several cleaning procedures are used depending on the surface condition of the base and the filler mill. Surface condition must also be encountered are as follows: scale free as received from the mill, light scale after hot forming and nailing an intermediate temperature at less than 1300 degrees Fahrenheit. Heavy scale after hot forming and annealing, forging at a high temperature. At a high temperature, metals are scale free to be cleaned with a simple decreasing. Metals are lightly oxide scale with the clean with the acid pickling, and in order to minimize hydrogen pickup, pickling solutions will operation should have nitric acid concentration greater than 20%. Metals to be welded should be pickled 1 for 20 minutes with bath time from 80 to 160 degrees Fahrenheit. After pickling, the parts are rinsed off in hot water, and metals are heavy scale, but they should be cleaned with the sand of the grit, the vapor grit, blasting molten sodium hydrate, salt bath, molten caustic bath, sand, grit vapor blasting preferred is where applicable. The hydrogen pickup may occur with the molten metal Bath treatments are minimized by controlling the bath temperature and pickling time. Both temperatures shall be held at 750 to 850 degrees Fahrenheit. Parts shall not be picked up any longer than necessary to remove the scale. After a heavy scale is removed, the metal should be pickled as described in 4 above. Alright, 6. Surfaces of the metal that have undergone oxyacetylene flame cutting operation have very heavy scale but may contain microscopic cracks due to the excessive contamination metallurgic characteristics of the alloy. The best cleaning method of the flame cut surfaces is to remove the contaminated layer. Any cracking machining operation keratin alloys can be stress relieved immediately after cutting to prevent the propagation of these cracks. These stress reliefs are usually made with conjunction with the cutting operation. Megan Welding Titanium, both. Megan TIG welding process use the welding titanium alloys are satisfactory for the manual automatic insulation. When these processes, contamination from the molten welded metals adjacent to the heat is effective is minimized, shielding the arc of the root of the weld with air with gases. C2B of the special backing bars and C2C. In some cases, an air gas of the filler welding chamber C3 are used to provide required shielding. When using TIG welding process, fluorinated tungsten electrodes shall be used. The electrode size shall be the smallest diameter will carry the welding current. The electrode shall be grounded to a point. The electrode may not exceed 1 and 1/2 times the diameter beyond the end of the nozzle. Welding is done with a direct current electrode negative straight polarity welding procedure for the TIG welding titanium is shown in figure table 728. Selection of the filler metal will depend upon the titanium alloys being joined. When welding pure titanium, a pure titanium wire shall be used for the welding of the titanium alloy. No lowest strength alloy shall be used for the filler wire due to the dilution which will take place dining in the weld with a weld deposit with a pickup with the required strength with the same considerations are true to when MIG welding titanium. Alright, shielding. General, very good shielding conditions. Used necessary to produce the arc welding joints of the maximum ductility toughness obtained with these conditions with the amount of the air with the other active gases with the contact with the molten weld metals. The adjacent heat affected zones must be very low. Argon is normally used for the gas shield process for a thicker user. Helium mixture, argon and helium. Well, the graded shielded gases are generally free of contamination. However, tests can be made before welding. Simple tests made by the bead on a piece of clean scrap titanium. Notice its color. The bead should be shiny. Any discolorization of surface indicate for the contamination. Extra gas shielding provides protection for the heated solid metal next to the weld metal. The shield is provided by special trailing gas nozzles or by chilling bars laid immediately next to the weld. Backup gas shields should be provided to protect underside of the weld joint. Protection over the backside of the joint can also be provided by placing chill bars in intimate contact with the backing strip, and if the contact is close enough, the backup shielding gas is not required for critical application use in an air gas welding chamber. These can cause flexible rigid vapor purge chambers. And then it shows the table. In air gases, both helium and argon are used as shielding gases for the helium or shielding gases welding speed for the better penetration obtained with the argon. Both arc is more stable than argon, but for opening air welding operation, most welders prefer argon as the shielding gas because it is density of the greater than that of air. Mixture of the argon and helium are also used with the mixture of the characteristics of both helium and argon are obtained. The mixture usually a very composition with about 20 to 80% argon. They are often used with consumable electrode process to provide adequate shielding. For the face and roof sides of the weld, special precautions often are taken. The precautions include the use of the screen baffles and trailing shields, special baking fixtures, and use of an air gas filler welding chambers. Open air welding. In open air welding operation, the method used with the shield of the face of the weld vary with the joint design, welding condition, thickness of the material being joined. The more critical area regarded with the shielding is molten metal welded pool. Impurities diffuse the molten metal more rapidly with the remaining solution. Gas flows through the same welding torch sensation with the shield of the molten zone. Because of the low thermal conductivity of titanium, however, the molten metal tends to be larger than most metals. For this reason, and because of the shielding conditions required with the welding of titanium, larger nozzle the welding torch, proportional higher gas flows that are required for other metals. Chill bars are often used to limit the size of the puddle. The primary source of the contamination of the molten weld metals are turbulence in the gas flow, oxidation, hot filler rods, insufficient gas flow, small nozzles or welding of the torch, and pure shielding gas. Later of the three sources are easily controlled. If the turbulence three, if this turbulence occurred with the gas flowing from the torch of the air inspired with the contamination will result. The turbulence is generally caused by the excessive amounts of the gas flowing from the torch along arc lengths and air currents blowing across the weld joint design. Contamination from this source can be minimized adjusting gas flows and arc lengths, placing baffles alongside of the welds. Baffle projects of the weld with draft that tend to retard the flow of the shielding gas from the joint area. Chill bars are clamping toes of the welding jig that can serve as baffles. Baffles are especially important for making corner type welds. Additional precautions can be taken to protect the operation from the draft and turbulence. This can be achieved by erecting a canvas or other suitable material screen around the work area. Alright, manual welding operation of the tungsten arc process with oxidation. Hot filler metal with a very important source of the contamination from the control of the hot end of the filler wire must be kept with the gas shield of the welding torch. Welding operators must be trained to keep the filler wire shield with the welded titanium and its alloys, even if proper manipulation. However, the contamination from the source probably cannot be eliminated completely. This shows your flat baffle arrangements improving shield. Welding contaminates occur with molten welded pool, and especially as with impurity of the go into solution, do not cause discolorization. Also, the discolored welds have not been properly shielded while molten welded discolorization usually comes with decontamination occurs after the weld is solidified. Most of the auxiliary equipment that can use the torches to weld the titanium is designed to improve the shielding conditions for the weld with solidifying with the cool. However, the welding heat input is low. Weld cools the temperature below the 1200 and 1300 degrees Fahrenheit, while auxiliary shielding equipment is not required. If the weld is excessively high temperature, after it is not longer shielded with the welding torch of the auxiliary shield must be supplied. Trailing shields are often used to supply auxiliary shielding. The shields extend the handle of the welding torch, very considerable in the size and the shape of the design. They are incorporated in special cups, which are used on the welding torch to make it consistent with only tubes of the hoses attached for the torp and ventilation by hand or direct stream of the inert gas of the welds. Figure 717 shows the drawing on one type of the trailing shield currently with the use of the important feature of the shield or the porous diffusion plates allows the even flow of the gas over the shield of the air. This will prevent the turbulence gas stream of the shield fits on the torch so the continuous gas stream between the torch and the shield is obtained. This shows the trailing shield. Your baffles are also beneficial. Improve the shield of the condition with the welds and retarded flowing of the shield of the gas and joint air. Baffles may be placed alongside of the weld, over the top of the weld, the ends of the weld. In some instances, they actually become over the chamber around the arc of the molten weld puddle. Also, chill bars may be used to increase the weld and cool rates, may make auxiliary. Very little difficulty to have encountered with the shielding of the face of the weld with the automatic welding operation. However, the considerable difficulty has encountered with the manual operation. An open air operation means to provide with the shield of the root of the back of the weld with the backing mixture often used with the purpose of the one type of the auxiliary supply of the inert gas is provided to shield the back of the weld and other solid or grooving backing bars to fit it together. It fits tightly against the back of the weld provided with the required shielding fixtures which provide an air gas should are preferred, especially in the manual welding operation with low welding speed. Figure 718 show the backing fixtures such as using butt weld, heavy plate, thin sheet, respectively. Similar type of fixtures are used for other joint design. However, the design of the fixture varies from the design of the joint. For fillet welds on T-joint, shielding should be supplied for two sides of the weld in addition to the shielding of the face of the weld. R11. For some applications, it may be easier to enclose the back of the weld with the tank of the more inert gas. The shielding purpose of the smith of the necessary welding tank tubes and other enclosed structure with the edge access for the back of the weld is not possible. Some other weldings for the may be necessary for the manholes, grooves, and structures in order to provide shielding gas for the back of the root of the weld. Warning: when using a weld backup tape, the weld must always be allowed to cool for several minutes before attempting to remove the tape from the workpiece. Use of the backing fixtures such as the shown figure 718 can be eliminated with in many cases of the welding backup tape. The tape consists of a center strip of the heat-resistant fiberglass adhered wider strip of aluminum and the foil along with a strip of the adhesive on each side of the center of the strip that is used to hold the tape on the underside of the tack of the weld joint during the welding. The fiberglass portion of the tape is in direct contact with the molten metal with the preventing the excessive penetration, contamination of the oxidation underside of the weld, preventing the airtight seal created by an aluminum foil strip. The tape can be used in butt corner joints or because of flexibility on curved or irregularly shaped surfaces to which the tape is applied must be clean and dry. Best results obtained by using root gap wide enough to allow full penetration. Alright, bending and notching toughness of the are best methods of evaluating shield condition visual inspection weld surfaces which are not infallible method. Only non-destructive means are evaluating welding quality at the present time. When this is the method, present a heavy gray scale with a non-metallic luster with a welded bead indicate that the weld has been contaminated with madly low ductility. Also, the weld surfaces may be shiny but have different colors ranging from the gray, bluish to violet brown. The type of the discoloration may be found severely contaminated welds may due only to the surface contamination, while the weld itself may be satisfactory. However, the quality of the weld cannot be determined without the destructive test. With a good shielding procedure, welding surfaces are shiny, no discoloration. Your welding chamber. For some application of the inert gas filled welding chambers are used with the advantages using such chambers. Good shielding may be obtained with the rooted face of the weld without special fixtures. Also, with the surface appearance of the surface of the weld, fairly reliable to measure for the shielding conditions. Use the chambers, especially advantages of the complex joints are being welded. However, the chambers are not required for many applications, but they may be limited. Welding chambers vary in size and shape, and depending on their size and size of the assembly to be welded, the air and atmosphere may be obtained within the inert gas, collapsing in the chamber to expel the air and refilling it with inert gas. Plastic bags have been used in later manner when atmosphere are obtained with the purging and the collapsing of the chamber. The inert gas usually is supplied with a welding torch to ensure complete protection of the weld. Alright, 4. Joint designs. Joint design for titanium are similar to those used for the other metals. For the within sheet, the tungsten arc process generally is used when the process of the butt welds may be with or without filler rod, depending on the thickness of the joint and the fit up. Special shearing procedures sometimes used so that the root opening does not exceed 8% of the sheet thickness. If the fit up is good and filler rod is not required, fit up is not the thickness of the fit up is not this good. Filler metal is obtained with the full thickness joints and welding thicker sheets greater than 0.9 hundredths or 2.3 millimeters. Both tungsten arc and consumable electrical processes are used for road opening and welding. Titanium plates are both forging. Tungsten arc consumable electrical processes are also used in single and double V joints. In all cases, welding penetration may be obtained with excessive drop through. However, the penetration drop out through are controlled more easily through the use of the proper bracking fixtures. Alright, no, because of the low thermal conductivity of titanium welding, bead tends to be wider than normal. However, the width of the bead is generally with the control of using short arc lengths and placing chill bars or clamping toes at J closing the sides of the joint. Alright, welding variables. Welding speed with the current of the titanium alloys dependent on the process. Use the shielding gas thickness of the material welded design with the backing fixtures, along with the spacing of the chill bars, clamping bars of the welding jig. Welding speeds vary from 3 to 40 inches per minute. The highest welding speed obtained with a consumable electrode process. In most cases, direct current is used for the straight polarity for tungsten arc process. Reverse polarity for use of the consumable electrode process. Arc Wander has proven troublesome in some of the automatic welding operation. While the arc wander and the arc of the tungsten consumable electrode moves from one side of the welding joint to the other, a straight uniform welded bead will not be produced. Arc wandering is believed to be caused by magnetic disturbance. Bends in filler wire with the coating of the filler wire with a combination of these. The special metal shield with the wire straighteners have been used to overcome a wanderer, have been not completely satisfactory, and also constant welding machines have been used in an attempt to overcome this problem. These machines also have not been completely satisfactory. And setting up the arc operation for the titanium and the welding conditions should be evaluated with the basis of the welding joint prior properties and appearance of the radiographs as shown of the porosity of the cracking present in the welding joint. Simple bend test, notch toughness test, which will show whether the knot or the shielding conditions are adequate. Visual examination will be shown if the weld and penetration contour are satisfactory. And after adequate procedure for the establishing, careful controls are desired to ensure that shielding conditions are not changed. Are weld defects. General defects or welding joints with the titanium alloys contain mainly porosity and cold cracks. Welding preparation can be controlled with adjusting welding conditions. Porosity. Welding porosity, a major problem with the arc welding titanium alloys. Other acceptable limits of the porosity arc weld joints have not been established, and porosity has been observed with the tungsten arc weld. Impractically, all alloys which appear suitable for welding operation does not extend, but the surface of the weld has been detected with the radiographs, usually occurs closely with the fusion line with the weld's warp weld porosity may be reduced aggregated, but will eliminate some of the sort of the porosity present after the first pass. However, the later method of reducing welding porosity tends to increase the welding contamination. Alright, cracks. 1. With adequate shielding procedure, the suitable alloy cracks should not be a problem. However, the cracks have with the troubleshooting with welding. Some of the alloys welding cracks are attributed with the number of the causes of commercial pure titanium welding. Metal cracks are believed to be caused with excessive oxygen or nitrogen contamination. These cracks are usually observed with the weld craters, and some alpha beta alloy transverse cracks are in the welded heat affected zones, believed to due to low ductility of the welded zone. However, the cracks of these alloys also be due to the contamination. Cracks also have been observed in alpha beta welds made during the resistance restraint and high external stress. These cracks are sometimes contributed to the hydrogen content of the alloy. Alright, note if the welding crack is due to the contamination, it may be controlled with improving shield conditions. However, the repairing of the weld excessive contaminated weld is not practical. Cracks which are caused with low ductile welds and alpha beta alloys can be prevented with a heat treating stress relieving of the welding welding furnace immediately after welding. Acetylene torches also have been used for this purpose. However, the care must be taken into that the weld net is not overheated, excessively contaminated by torch heating operation. 3. Cracks due to hydrogen may be prevented with the vacuum annealing treating prior to the welding. Availability of filler wire. Most of the titanium alloys being used with the welding application are available to wire for use as well as filler metal. These alloys are listed below: commercial pure titanium, and there has not been a great deal of need for the other alloys of the welding filler metals. However, the size of the needs, the curve of them must also become reduced to wire. In fact, the titanium 8 magnesium alloy has been furnished as well as wire to meet some of the requests. Pressure welding. Solid phase pressure welding has been used to join titanium alloys. Process the surfaces to be joined but not melted, held together under pressure, heated with the evaluated temperature. One method of heating is used for the pressure welding. Acetylene flame, the suitable pressure upset and good welds are obtainable with a high-strength alpha beta titanium alloys contained with air and or surface of the weld with the display for the joint area of the upset which occurred during the weld with the contaminated surface of the machine off after the welding. Another method of heating by heat dyes with the strong lap joints are obtained with which the method of the commercial pure titanium high-strength alpha beta alloy by heating them in the matter weld made by in very short periods of time and air gas shielding may be supplied to the joint with all the heating of the methods. Less than 2 minutes are required to complete with the welding operation with the solid phase pressure welding processes. It's possible to produce ductile welds of the high strength alpha beta alloys by using temperature which does not cause embrittlement in these alloys. Alright, nickel monotile welding. Nickel is a hard malleable ductile metal. Nickel is also commonly used for the corrosion resistant required nickel alloys. Which model can be welded in metal or gas welding methods. Single nickel alloys are more difficult to weld during the different composition. Operators should make a trial weld with very reverse polarity of several current values and select the one best suited for the work. Generally, oxyacetylene welding methods are preferred with the smaller plates. However, the small plates can be welded with the metal arc and the carbon arc process. The large plates are more satisfactorily joined, especially if the plate is nickel-clad steel. When welding, nickel alloys can be treated within the same manner as the synthetic stainless steels. A few exemptions. These exempt are the nickel alloys will acquire a surface of coating which melts at the temperature approximately 1,000 degrees Fahrenheit above the melting of the base metal. Nickel alloys are suspected with the embrittlement of the welding temperature. Lead, sulfur, phosphorus, some low-temperature metal and alloys. 3. Welding penetration is less expected than the other metals. When composition is made with these factors, the welding procedure used for the nickel alloys could be the same as the other than stainless steel. This is because of the melting point coefficient, thermal expansion, and the thermal conductivity are similar to austenitic stainless steel. It is necessary that each of these precautions be considered. The surface oxide should not be completely removed with the joint air, grinding, and abrasive blasting. But machining chemical meaning the chemical edges are used. They must be completely removed without rising prior to the welding. Oxide, which melts at the temperature above the melting point with the base metal with the enter of the weld, is the foreign material impurity will greatly reduce the strength and the ductility of the weld. The problem of embrittlement welding temperatures also mean that the welding surface must be absolutely clean. Paints, crayon, markers, grease, oil, machine lubricants, cutting oils may also contain the ingredients which will cause embrittlement. They must also completely remove the welding area to avoid embrittlement. It is necessary to increase the opening of the groove angle and to provide adequate root opening. Full penetration welds are used. The bevel and groove angles should be recurved approximately 40% over the used for carbon steel. Joint design. Butt joints are preferred with butt corner and lap joints can be effectively welded Beveling is not required on plates for 1/16 and 1/8 of an inch thick, with thicker plates and bevel of 35 to 37.5 degrees should be made when welding laps, which should be made entirely with nickel electrodes and water, if water and airtight tightness is required. Our welding technique: clean all surfaces to be welded with either mechanically or machine sanding, blasting, grinding with abrasive cloth with chemical pickling. Plates used the AU or V joint should be assembled in nickel-clad steel should be tacked on the steel side to prevent warping and distortion. Average determine the joint is even and flat and complete with a weld on the steel side. Chip out and clear the nickel side of the weld if the base of the bowl for the side with the nickel. Clean out with the groove on the weld side prior to the beginning of the weld on that side. If the design of the nickel side may be completed first, however, the steel of the side must be tacked and thoroughly cleaned, beveled, the groove gouged down to the root of the nickel, welded prior to the welding. Lap and core joint successfully welded, depositing a bead of the nickel metal with the root open, with a weaving successive beads over the root weld. Arc drawn with the nickel alloy welding should be slightly shorter than those using the metal arc. Normal metal arc welding, 1/16 to 1/8 of an inch arc necessary. R6. Any position weld can be accomplished that can be satisfactorily welded with normal metal arc welding of steel. Welding methods. Almost all welding processes can be used with the welding of the nickel alloys. In addition, they can be joined with the brazing and soldering. Welding nickel alloys. Popular process for the welding nickel air shield metal arc welding process for the gas tungsten arc welding process for the gas metal arc welding process. Process selection depends on the normal fact that shielding metal arc welding is used. The procedure is essential but the same as those used in the stainless steel welding. Welding procedure scheduled to use the gas tungsten arc welding is shown in table 729. The welding procedure scheduled for the gas metal arc welding is shown in table 738 The procedure information set forth in these tables will provide the starting points for the developing welding procedure. No post-weld with the heat treatment is required to maintain rust or corrosion resistant with the nickel alloys. Heat treatment is required with the precipitating hardening alloys. Stress relief may be required to maintain certain specifications to avoid stress corrosion cracking. Application involving hydrofluoric acid vapors and caustic solutions. Chapter 8. Electrodes and filler metal. Testing.